Hello friends, this is the miscellaneous exercise for the chapter number 1. Now let us start. First question. Choose the correct option. From the given alternative. First, let f of 1 is equals to 3, f dash of 1 is equals to minus 1 upon 3, g of 1 is equals to minus 4, g dash of 1 is equals to minus 8 upon 3. Then find the derivative of, that is in root of f of x bracket square plus g of x bracket square with respect to x at x is equals to 1. The first is minus 29 upon 15, b 7 upon 3, c 31 upon 15, d 29 upon 15. Now let us start the answer. We have given that y is equals to in root of f of x bracket square plus g of x bracket square. Now differentiate. This is similar to derivative of root of x. The derivative of root of x is 1 upon 2 times root x. dy by dx is equals to 1 upon 2 times in root of f of x bracket square plus g of x bracket square into ddx of, because this is the composite function, into the ddx of f of x bracket square plus g of x bracket square. That is equals to 1 upon 2 times in root of f of x bracket square plus g of x bracket square is equals to 2 times f of x into f dash of x plus 2 times g of x into g dash of x. Now take 2 as a common, then f of x into f dash of x plus g of x into g dash of x upon 2 in root of f of x bracket square plus g of x bracket square. 2 get cancelled. And now substitute the value of, we want to find out at x is equals to 1. Replace x by 1. f of 1, f dash of 1, g of 1, g dash of 1, f of 1 bracket square plus g of 1 bracket square. Their values, f of 1 is a 3, f dash of 1 is equals to minus 1 upon 3, g of 1 is minus 4, g dash of 1 is a minus 8 upon 3, this whole divided by 3 square plus minus 4 square, that is minus 1 plus 32 upon 3, 25, root of 25, 29 upon 3 upon 5, that is a 29 upon 50, and hence the option D is the correct one. Now see this answer again. If you want to, this is the answer. If you want to write down the answer of this question, it's the derivatives ddx of this quantity. The function is a composite function, 1 upon 2 times. Take 2 as a common and then substitute the values. This is the derivative of f of x. 2 times f of x into f dash of x plus 2 times g of x into g of x. Take 2 common, at x is equals to 1. You have these values 1, 3, f dash minus 1 by 3, g minus 4, g dash minus 8 upon 3. Upon in root of 3 square plus in bracket minus 4 square. You are getting the value which is 29 upon 15, and hence option D is the correct one. Now the next. If y is equals to, say, in bracket tan inverse of x, then dy by dx at x is equals to 1 is equal to a 1 upon 2, b 1, c 1 upon root 2, and d root 2. Y is equals to sec of tan inverse of x. Now differentiate this with respect to x. Therefore, dy by dx is equals to sec of tan inverse, derivative of sec of x into tan of x, sec of x, sec of tan inverse of x into tan inverse of x into ddx of tan inverse of x. So sec of tan inverse of x as is, but tan inverse of tan of x is x, and ddx of tan inverse of x is 1 upon 1 plus x square. Therefore, dy by dx is equals to sec of tan inverse of x in at x is equals to 1. We are substituting the at x is equals to 1. Therefore, sec of tan inverse of 1 upon 1 square, that is 1. And now sec tan inverse of 1 is pi by 4. Next is, that is sec of pi by 4 into 1 upon 2, which is 2 upon 2, and hence that is a root 2 upon 2, which is 1 upon root 2. Now see this again here. Their derivatives, sec tan inverse of x into tan inverse of x into ddx of tan inverse of x. Tan inverse of tan of x is x. Sec of tan inverse of x into 1 upon x square. At x is equals to 1. Tan inverse of 1 is pi by 4. 1 upon 2. Sec of pi by 4. This is the root 2 upon 2. Root 2 upon 2 means what? 1 upon root 2. And hence option C is the correct one. Number 3. Question number 3. If f of x is equals to sine inverse of 4 raised to x plus 1 upon 2 upon 1 plus 2 raised to 4x. Which of the following is not the derivative of f of x? Now we have sine inverse of 4 raised to 1 upon 2, 4 raised to x, that is a sine inverse 4 raised to 1 upon 2. That is a 2 square root of 4 is 2 into 4 raised to x plus 4 raised to 2x. Now put 4 raised to x is equals to tan theta, and that's why theta is equals to tan inverse of 4 raised to x. Therefore y is equals to sine inverse of 2 tan theta upon 1 plus tan square theta. That is a sine inverse of sine of 2 times theta, and that is equals to 2 theta. But what is a theta? Theta is a tan inverse of 4 raised to x, and that's why its derivative is, differentiate this now with respect to x. Dy by dx is equals to, that is a 2 upon 1 plus 4 raised to x bracket square into ddx of 4 raised to x. What is the derivative of 4 raised to x? That is 4 raised to x into log of 4. Two upon 4 raised to 2x into derivative of 4 raised to x is 4 raised to x into log of 4. Therefore, 2 into 4 raised to x upon log of 4 upon 1 plus 4 raised to 2x. Now, the answers can be written in this manner. That is a 2 into 4 raised to x log of 4 upon 1 plus 4 raised to 2x is written as like this. Now how this is? This is the 4. 4 means what? 2 raised to 2. When by using the power, then it becomes 4. Therefore 4 log of 4, 4 raised to x log of 2. Next is, this is power 4, 1 power, and this is x. That is 4 raised to x plus 1 log of 2 upon 1 plus 4 raised to 2x Next is 2 raised to 2 in bracket x plus 1 log of 2 upon 1 plus 4 raised to 2x. Hence option C is the correct one. Now see the second answers. Let's given the function f of x, substitution tan theta is equals to 4 raised to x, theta is equals to tan inverse of 4 raised to x. Therefore y is equals to sine inverse of 2 tan theta upon 1 plus tan square theta. If we simplify this, then you will get sine inverse of sine of 2 times theta, and that is equals to 2 theta. Theta is a tan inverse of 4 raised to x. Now differentiate this with respect to x. That is this is a 2. Tan inverse of 4 raised to x means what? 1 upon 1 plus 4 raised to x bracket square into ddx of 4 raised to x. What is the derivative of 4 raised to x? 4 raised to x into log of 4. Now all these answers can be written as now. This is a 2. 4 raised to x log of 4 upon 1 plus 4 raised to 2x. Now again this 4 means what? 2 raised to 2. When this 2 comes here, then it becomes 2 into 2, 4. 4 raised to x into log of 2. Next is this 4 raised to 1 and 4 raised to x. It becomes 4 raised to x plus 1 log of 2 upon 1 plus 4 raised to 2x. What's happening next? That is a 4. 4 means what? 2 raised to 2. That is a 2 raised to 2 in bracket x plus 1 log of 2 upon 4 raised to 2. That is all the options which is a is present there. A can be converted, B, D. Only the option C is not there. Therefore, this is the incorrect. Okay? We cannot express like this. Therefore, answer is C again. Now the next is if x raised to y is equals to y raised to x, then dy by dx is equals to x in bracket x log y minus y upon y in bracket y log x minus x, b y in bracket y log x minus x upon x in bracket x log y minus y, c y square in bracket 1 minus log x, x square in bracket 1 minus log of y, and t y in bracket 1 minus log x upon x in bracket 1 minus log of y. Now see the problem. X raised to y is equals to y raised to x. Take log on both sides. Therefore, you will get y log x is equals to x log y. That's the simple one. If you take the log, y log x is equals to x log y. Now differentiate this with respect to x. Apply the product rule here. Also apply the product rule here. Keep y as it is, log of x, its derivative is 1 upon x, next, plus log of x into derivative of y, which is dy by dx. This is the derivative of y, dy by dx. Now same thing is here. Derivative of x is 1 into log of y. Derivative of x is 1 log of y plus x into, what is the derivative of log of y? 1 upon y into dy by dx. Now collect the term of the dy by dx. Now this is a y upon x log of x into dy by dx minus x upon y into dy by dx is equals to log of y. This is the, if you take dy by dx common, then in bracket you will get log of x minus x upon y into dy by dx is equals to log of y minus y upon x. Therefore, now simplify this. Here is simplification, y into log of x minus x upon y. On this side, x log of y minus y upon x. Therefore, dy by dx is equals to y into x log of y minus y upon this. Now see this here, dy by dx is equals to x log of y minus y. But where is this y? This y is come from here. It is here. Next is, this is x and denominator term, that is the y log of x minus x is here. Therefore, dy by dx is equals to. Now we have the values. That is the dy by dx is equals to y upon x. The value of x log y is equals to y log x minus y upon x log y, the value of y log x log y minus x, that is y is common from the numerator and the x is common from the, it becomes x square to the denominator in bracket log of y minus 1. Therefore, dy by dx is equals to take minus sign common from the numerator and the denominator, then you will get, that is option C is the correct one. That is y square in bracket 1 minus log of x upon x square in bracket 1 minus log of y. Here is a correction in the answer. My answer is C. Okay. If you are agree, then write down this. If you are not agree, then don't write this. Now the question number, I will repeat again this question. This is the x raised to y is equals to y raised to x. Then this is x raised to y is equals to y raised to x. Take log on both sides. Y log x is equals to x log y. Differentiate with respect to x. Y log of x 1 upon x. Log of x as it is. Derivative of y dy by dx plus derivative of x is 1 log of y plus x as it is, derivative log of y is derivative 1 upon y into derivative of y dy by dx. Next is, this is y upon x plus log of x into dy by dx. Next is, this is x upon y into dy by dx to the left hand side is equals to log of y. Now simplify this. What's the simplification? Take log of y dy by dx as a common. Then you will get log of x minus x upon y into dy by dx is equals to log of y minus y upon x. Simplify this. That is y log x minus x upon y into dy by dx. Simplify this. X log y minus y upon x. Then find, then you are getting dy by dx. Now here we have x log of y is equals to y log x. X log of y is equals to y log x. And we substitute their values. If you take the common from the numerator, that is y, and denominator x, then you are getting x square in bracket 1 minus log x. Sorry, y square in bracket 1 minus log x upon x square in bracket 1 minus log of y. And hence we have the answer. Therefore option C is the correct one. Next is fifth one. If y is equals to sine 2 sine inverse of x, then dy by dx is equals to 4 minus 2x square upon in root of 1 minus x square. B is 2 plus 4x square upon in root of 1 minus x square. C is 4x square upon in root of 1 minus x square. D is 1 minus 2x square upon in root of 1 minus x square. Y is equals to sine of 2 sine inverse of x. Now differentiate this with respect to x. Derivative of sine is cos 2 sine inverse of x into ddx of sine inverse of x. The derivative of sine inverse of x is 2 upon in root of 1 upon in root of 1 minus x square. Therefore 2 cos of 2 sine inverse of x upon in root of 1 minus x square. Therefore dy by dx. Now here is the cos of 2 times theta is equals to, what's the value? Therefore it's converted like this, 1 minus 2 sine square sine inverse of x. Now what is here? This is the 2x square. Therefore 2 in bracket 1 minus 2x square upon in root of 1 minus x square, and hence the answer is 2 minus 4x square upon in root of 1 minus x square. Therefore dy by dx is equals to 2 minus 4x square upon in root of 1 minus x square. Hence option A is the correct one. Now see this again. Y is equals to normal differentiation is here. Now what is it? Cos of 2 times theta means what? Cos square theta minus sin square theta. Therefore we write here cos square of sin inverse of x minus sin square of sin inverse of x. Now this cos square means what? 1 minus sin square, and therefore it becomes 1 minus 2 sin square sin inverse of x. But what is the sin square of sin inverse of x? Is x square. That is 1 minus 2x square upon in root of 1 minus x square. If you multiply with by 2, then you will get 2 minus 4x square upon in root of 1 minus x square. Therefore dy by dx is equals to 2 minus 4x square upon in root of 1 minus x square, and hence option A is the correct one. Next is number 6. If y is equals to tan inverse in bracket x upon 1 plus in root of 1 minus x square plus sine in bracket 2 tan inverse of in root of 1 minus x upon 1 plus x bracket complete. Then dy by dx. The first is x upon in root of 1 minus x square. B 1 minus 2x square upon in root of 1 minus x square. C 1 minus 2x upon in root of 2 in root of 1 minus x square. D 1 minus 2x square upon in root of 1 minus x square. Put x is equals to cos of 2 times theta. Therefore y is equals to tan inverse of cos of 2 times theta upon 1 plus in root of 1 minus cos square of 2 theta plus sine of tan inverse in bracket 1 minus x upon, that is 1 minus cos of 2 times theta upon 1 plus cos of 2 times theta. Therefore, if you substitute the values, then you will get, see this value again. I will repeat again. Now here cos of 2 times theta means what? Cos square theta minus sin square theta upon 1 plus in root of 1 minus cos square 2 theta means what? Sin square 2 theta. Square and root get cancelled. You will get 1 plus sin of 2 times theta. Next is sin minus 2 tan inverse in root of 1 minus cos of 2 times theta means what? 2 sin square theta. That is a 2 sin square 2 theta upon 2. Then you get 2 sin square theta upon 1 plus cos of 2 times theta means what? 2 cos square 2 theta upon 2. That 2 get again cancelled. This 2 get cancelled. You are getting the tan square theta, and its a square root is a tan theta. Now see this next. Here is a, that is a, but what is here 1? 1 means what? Cos square theta plus sin square theta. Sine of 2 times theta means what? 2 sin theta into cos theta. Plus sine in root of 2 tan inverse of in root of tan square theta. And that's why, next step, see this here. That is the tan inverse of cos of theta minus sin theta into cos of theta plus sin theta upon cos theta plus sin theta bracket square plus sine of in bracket 2 tan inverse of tan of theta. But tan inverse of tan of theta is, this is the theta, which is here 2, therefore it is a 2 theta. This is a sine of 2 times theta. Now what's happening here? This is always very famous and special. Divide numerator and the denominator by cos theta. Then you will get 1 minus tan theta upon 1 plus tan theta. And that is nothing but the expansion of tan of pi by 4 minus theta. Now the next is tan of pi by 4 minus tan theta. That is the tan of pi by 4 minus theta. If this continues, sine of 2 times theta as it is. Now tan inverse of tan of pi by 4 minus theta is nothing but pi by 4 minus theta. Therefore, now sine of 2 times theta can be written as in root of 1 minus cos square 2 theta. But what is x? X is equals to cos of 2 times theta. Therefore, 2 theta is equals to cos inverse of x. This big problem, and theta is equals to 1 upon 2 cos inverse of x. But these are the multiple choice. You can solve by using the trick method. But what are their solutions? That's I am giving here. Now here pi by 4 minus theta plus in root of 1 minus x square. That is the value of x is equals to cos of 2 times theta. So value. That is y is equals to pi by 4 minus 1 upon 2 cos inverse of x. Here is x, by mistake I forget to write it, plus in root of 1 minus x square. I will change it. Now differentiate this with respect to x. dy by dx is equals to pi by, derivative of pi by 4 is 0. And what is the derivative of cos inverse of x? That is a minus 1 upon in root of 1 minus x square. That minus minus will become plus here, plus derivative of root of 1 minus x square. What is the derivative of root of 1 minus x square? That is 1 upon 2 in root of 1 minus x square into ddx of 1 minus x square. Derivative of 1 is 0 and derivative of x square is a 2x. That is ddx of, that is 1 upon 2 in root of 1 minus x square minus 2x upon in root of, this 2 get cancelled. Therefore dy by dx is equals to 1 minus 2x upon 2 in root of 1 minus x square. Therefore, option C is the correct one. Now see this again answer. This was the big one. Then you will get x is equals to cos of 2 times theta. That's substitutions. Y is equals to tan inverse sine of 2 tan theta in root of 1 minus cos of 2 times theta 1 upon 1 plus cos of 2 times theta. This is the big one. And these are the normal problems. If you have studied all the exercise very accurately, then you can understand this. Now express this whole in terms of, that is x, which is the x as a variable. This is the here is x, 1 upon 2 cos inverse of x. Therefore differentiate this with respect to x. Pi by 4 0, cos inverse is minus, and this minus minus will become plus. That 1 upon 2 into 1 upon in root of 1 minus x square, and derivative of root of 1 minus a square, that is 1 upon 2 times in root of 1 minus a square into ddx of 1 minus x square, and overall you are getting this answer. That is C is the correct one. Now we'll see the next. 7th one. If y is equals to, that is if y is a function of, every time it is a y is equals to, that's why, if y is a function of x and log of x plus y is equals to 2xy, then the value of y dash of 0 is a is 2, b is 0, c is minus 1, d is 1. Now log of x plus y is equals to 2xy. Differentiate this with respect to x. What is the derivative of log of x? That 1 upon 1 plus 1 upon x plus y into ddx of x plus y. Apply here product rule. Derivative of x is 1 into y. Derivative of x is 1 into y plus x into derivative of y, dy by dx. That is 1 upon x plus y into ddx of x is 1, y is dy by dx. And that is equals to 2y plus x into dy by dx. Therefore, 1 upon x plus y plus 1 upon x plus y into dy by dx is equals to 2y plus 2x into dy by dx. Now collect the terms of the dy by dx on one side and then simplify. 1 upon x plus y into dy by dx minus 2x into dy by dx is equals to 2y minus 1 upon x plus y. If you take dy by dx as a common, then 1 upon x plus y minus 2x into dy by dx is equals to 2y into x plus y minus 1 upon x plus y. On this side, 1 minus 2x in bracket x plus y upon x plus y into dy by dx, that is equals to 2y in bracket x plus y minus 1 upon x plus y. Now these two terms get cancelled, and that's why dy by dx is equals to 2y in bracket x plus y minus 1 upon 1 minus 2x in bracket x plus y. Now when x is equals to 0, Then log of x plus y is equals to 2xy. That is log of y is equals to 0. Therefore, y is equals to e raised to 0, which is 1. This is important. We are finding the value of y. We have given that x is equals to 0. Substitute here. You are getting y is equals to, this is logarithmic, it's converted into the exponential, it becomes e raised to 0 is equals to 1. Y is equals to 1. And that's why x is equals to 0, then y is equals to 1. Therefore, dy by dx is equals to 2y in bracket x plus y upon minus 1 upon 1 minus 2x in bracket x plus y dy by dx at x is equals to 0, 2 into 1, 0 plus 1 minus 1, one minus, that overall will become 0. That is the 2 minus 1, the answer will be the 1. Therefore, dy by dx at x is equals to 0 is 1. That is D option is the correct one. Now see the same solution of this question. If y is a function of x, log of x plus y is equals to 2xy. Then the value of y dash of 0. This is a log. It's a derivative. Collect the term of the dy by dx. Simplification. Normal simplification. Add explain. That is 2y into x plus y minus 1 upon x plus y. Next is 1 minus 2x into x plus y upon x plus y. It get cancelled. When x is equals to 0, we are getting the value of y, which is 1. And substitute it in this dy by dx. Then you are getting dy by dx at x is equals to 0 is 1. Now the next is, if g is the inverse of a function, f, and f dash of x is equals to 1 upon 1 plus x raised to 7, then the value of g dash of x is equals to now g is the inverse of x. G is the inverse of f. Therefore, f of g of x is equals to x. Now differentiate this with respect to x, which is the identity. That is, therefore f dash of g of x, if we differentiate it, derivative of f of is f dash into g dash of x is equals to 1. But the g is the inverse of f. Therefore, f dash of x we have given, that is 1 upon 1 plus g of x bracket raised to 7 into g dash of x. Therefore, g dash of x is equals to 1 plus g of x bracket raised to 7. see this here. We have given this. Okay. This is g is inverse of x. F of g of x is equal to x. Differentiate. F dash of g of x is equals to g dash of x is equals to 1. But what is the f dash of g of x? F dash of x is a 1 upon 1 plus g of x bracket raised to 7. This is the f dash into g dash of x is equals to 1. Therefore, g dash of x is equals to 1 plus g of x bracket raised to 7. And hence option C is the correct one. Now the next is if x in root of x plus y plus x plus y in root of x plus 1 is equals to 0 and x is not equals to 0, then dy by dx is equals to 1 upon 1 plus x bracket square b minus 1 upon 1 plus x bracket square c 1 plus x bracket square and d minus x upon x plus 1. Squaring on both sides, we have given that this is the x in root of y plus x plus y in root of x plus 1. Therefore, x in root of y plus 1 is equals to minus y in root of x plus 1. Now, squaring on both sides, then you will get x square in bracket y plus 1. And another side, y square is equals to in bracket x plus 1. That is x square plus x square y square x plus y square. Collect the term x square minus y square is equals to y square x minus x square y. Now split up this. This is xy in bracket y minus x. These two get cannot cancel. We have to take the minus sign common first, then cancel it. Now cancel it. Therefore, x plus y is equals to minus xy. The normal simplification where x minus y is x. We are cancelling because of x minus y is not x is not equals to y or x minus y is not equals to 0. Therefore, next is now differentiate this with respect to x. Derivative of x is 1, y is a dy by dx, and minus xy. What is here? Derivative of x is 1, y minus x, and derivative of y is a dy by dx. Collect the terms of the dy by dx. That is 1 plus, now this is important, that is 1 plus dy by dx minus y minus x into dy by dx. If you collect this, then you will get 1 plus x into dy by dx. These are the terms of the dy by dx. On the other side, this one comes here, it becomes minus. And take minus sign as a common. Therefore, dy by dx is equals to minus in bracket y plus 1 upon 1 plus x. Therefore, but x plus y is equals to minus xy. Y plus xy is equals to minus x. Again, this is simplification. Y is equals to, in terms of x, minus x upon 1 plus x. Therefore, now 1 plus y is equals to 1 minus x upon 1 plus x. If you simplify it, then you will get one upon 1 plus x. This is the value of y plus 1. Now substitute there. dy by dx is equals to minus 1 upon 1 plus x into dy by dx is equals to minus 1 upon 1 plus x into 1 upon 1 plus x. That is minus 1 upon 1 plus x bracket square. Therefore, the answer B is the correct one. Now, next is this is the problem. X in root of y plus 1 plus y in root of x plus 1, squaring on both sides. Then you will get x plus y is equals to minus xy. If we evaluate this, differentiate, dy by dx is equals to minus y plus x, y plus 1 upon 1 plus x, and then find the value of that is y plus 1. Y plus 1 is 1 upon 1 plus x. Put here, then dy by dx is equals to minus 1 upon 1 plus x square. Now the next is tenth one. If y is equals to tan inverse in bracket in root of a minus x upon a plus x, where the values of x lies between minus a to plus a, then dy by dx is equals to. Now put x is equals to a cos theta. Therefore, cos theta is equals to x upon a. Theta is equals to cos inverse of x upon a. Y is equals to tan inverse in root of a minus a cos theta upon a plus a cos theta. If you take a as common, then in bracket you will get a get cancelled. 1 minus cos theta upon 1 plus cos theta. That is the tan inverse of in root of 1 minus cos theta means what? 2 cos square theta by 2 sin square theta by 2 upon 2 cos square theta by 2. These two get cancelled. You are getting the tan of theta by 2. Tan inverse of tan of theta by 2. And that is nothing but the theta by 2. Therefore, y is equals to theta by 2. Y is equals to 1 upon 2 cos inverse of x upon 2. Now differentiate this with respect to x. Therefore, dy by dx is equals to 1 upon 2 minus, it's a derivative. What's its a derivative? Cos inverse of x upon a, its a derivative is a minus 1 upon in root of 1 minus x upon a bracket square into ddx of x upon a. Derivative of x is 1, which is 1 upon a. So it's 1 upon 2. Now simplify this. This is simplification. A get cancelled. That is a minus 1 upon 2 in root of a square minus x square. This is the dy by dx. Therefore, option C is the correct one. That is a minus 1 upon 2 in root of a square minus x square. Now see this again answer. Y is equals to tan inverse in root of a minus x upon a plus x. Put x is equals to cos theta. Theta is equals to x upon a. Theta is equals to cos inverse of x upon a. This we can calculate. You know this. That is a y is equals to theta by 2. But what is theta? Theta is a cos inverse of x upon a. Theta is the cos inverse of x upon a. Now differentiate this. dy by dx is equals to. Therefore, dy by dx is equals to. If we simplify this, then minus 1 upon 2 in root of a square minus x square upon a square root. If we take the square root of a square, then this a get cancelled. Therefore, dy by dx is equals to minus 1 upon 2 in root of a square minus x square. Here, therefore, option C is the correct one. Now, the 11th one is if x is equals to a cos theta plus theta sin theta and y is equals to a sin theta minus theta cos theta. Then find d2y by dx square at theta is equals to pi by 4. These are the options. Now we have x is equals to and y is equals to. These are dx upon d theta. Derivative of cos theta is minus sin theta and theta into sin theta. Apply the product rule. Derivative of theta is 1 sin theta plus theta. Derivative of sin theta is a cos theta. Now here sin theta and minus sin theta get cancelled. You are getting the theta cos theta. What about the dy by d theta? That is a. Derivative of sin theta is a cos theta minus theta into cos theta. Derivative of theta is 1 cos theta minus theta into sin theta. If we simplify it, then plus cos theta minus sin cos theta get cancelled. Therefore, dy by d theta is equals to a theta into sin theta. Dx upon d theta is equals to a theta into cos theta. Take their ratios. That is the dy by dx is equals to dy by d theta upon dx upon d theta. That is equals to tan theta. Now differentiate again with respect to theta. Now again by the chain rule. Therefore, ddx of dy by dx is equals to ddx of tan theta. d2y by dx square is equals to dd theta of tan theta into d theta upon dx. Derivative of tan theta is a sec square theta and into 1 upon here is a its value a into theta into cos theta. And if we simplify it, that d2y by dx square is equals to 1 upon a theta into cos cube theta. Therefore, d2y by dx square at theta is equals to pi by 4. Theta is equals to pi by 4. This is pi by 4. Cos cube of pi by 4. That is 1 by root 2 cos cube. That is 1 by 1 upon 2 root 2 and pi by 4. This is a pi by 4 1 upon 2 root 2. If you simplify it, then you will get 4 2 root 2 upon pi a. And that's why 4 into 2, it's a 8 root 2 upon a pi. Therefore, d2y by dx square at theta is equals to pi by 4 is 8 root 2 upon a pi. Therefore, the option A is the correct one. Now, see this again here. Problem number 11. X is equals to a cos theta plus theta sin theta. Y is equals to a sin theta minus theta cos theta. Then d2y by dx square at theta is equals to pi by 4 8 root 2 upon a pi minus 8 root 2 upon a pi upon 8 root 2, and d 4 root 2 upon a pi. Therefore, x is equals to a cos theta plus theta sin theta, y is equals to a sin theta minus theta cos theta. Therefore, now differentiate with respect to theta. That is, the dx upon d theta is equals to a minus sin theta plus derivative of theta and sin theta. Apply the product here. 1 sin theta plus theta cos theta. Simplify this. Plus sin theta minus sin theta get cancelled. You are getting a in bracket theta cos theta. This is the dx upon d theta. Similarly, dy upon d theta, a derivative of sin theta is a cos theta, and apply the product rule. Minus derivative of theta is 1 cos theta minus theta derivative of cos theta is minus sin theta. Plus cos theta minus cos theta get cancelled. You are getting the dy upon d theta is equals to a in bracket. Minus minus will become plus a sin theta. Therefore, that will become, that's a dy by d theta is equals to, that a is not here, it's a theta. That is a in bracket theta into sin theta. This is dx upon d theta is a in bracket a cos theta, and dy by d theta is a in bracket theta sin theta. Now dy by dx is equals to dy by d theta upon dx upon d theta. What are their values? That is a theta sin theta upon a theta cos theta. That is nothing but the tan theta. Now differentiate again with respect to theta. Therefore, d2y by dx square d2y by dx square dd x of tan of theta. And now by chain rule, that is a d2y by dx square is equals to dd theta upon tan theta into d theta upon dx. That is a sec square theta into d theta upon dx. Its value, we have find out it, which is 1 upon a theta into cos theta. Now simplify this. That will become a theta cos cube theta. This is d2y by dx square. But we want to find out at theta is equals to 5 by 4. Therefore, a into pi by 4 into cos cube of pi by 4. A into pi by 4. Cos cube pi by 4 means 1 upon root 2 bracket cube. A into pi by 4. 1 upon 2 root 2. Simplify. 8 root 2 upon a pi. After simplification we will get 8 root 2 upon pi. Eight root 2 upon pi a. Eight root 2 upon pi. Therefore, option A is the correct one. Now the next is question number 12. If y is equals to a cos of log x and a into d2y by dx square plus b dy by dx plus c, then the values of a, b, c are Then the values of a, b, c are x square minus x minus y, b x square xy, c x square x minus y, and d x square minus x y. Therefore here y is equals to a cos of log x. Now differentiate this with respect to x, that is the dy by dx is equals to a derivative of cos is the minus sine log of x into ddx of log x is 1 upon x. Therefore x into dy by dx is equals to minus a sine of log x. Now differentiate again this with respect to x. X into d2y by dx square plus derivative of x is 1 into dy by dx is equals to minus a cos of log of x into derivative of log of x, which is 1 upon x. Therefore, if we simplify this, that is multiplied the whole equation by x, then it will become x square d2y by dx square plus x into dy by dx is equals to minus a cos of log x. Therefore, x square into d2y by dx square plus x dy by dx minus y. This is the value of the y which we have given. A cos of log x is y. Therefore, x square d2y by dx square plus x dy by dx plus y is equals to 0. Now the coefficient of d2y by dx square, which is x square. The value of first is x square. All options are there. The b is x. B is x. Only second and third option. And c is plus y. Therefore, only answer B is there. B is the correct one. Now see this again, how it is solved. First derivative, nx into dy by dx minus a sine of log x. Again differentiate. Normal derivative, apply the product rule. Multiply on both sides by x. Value of a cos of log x is 1. Compare with the coefficients. The value of a, b, c. A is x square, b is x, c is 1. Therefore x square, x and y. And hence the multiple choice we have completed this question number 1. Solve the following. F of x is equals to minus x is equals to 2x is equals to 18 minus x upon 4, where the values of x lies between 2 to x lies between minus 2 to 0, 0 to 2, and for 2 to 7. Next is g of x is equals to 6 minus 3x for x lies between 0 to 2 is equals to 2x minus 4 upon 3 for the values of x lies between 2 to 7. Let u is e of x is equals to f of g of x and v is equals to g of f of x. Wx is equals to g of gx Find each derivative at x is equals to 1. If exist, find u dash of 1, v dash of 1 and w dash of 1. If it exists, then explain why. Now solve these questions. This is the question to your practice. Now we'll start the next question number 2. The values of f of x, g of x and f dash of x, g dash of x are given in the following table. The values are x is minus 1 and 2, f of x is 3. This is the table that you can see from textbook. Match the following. A group function, B group their derivatives. First is ddx of f of g of x at x is equals to minus 1. B ddx of g of f of x minus 1 at x is equals to minus 1. C ddx of f of x minus 3 is there at x is equals to 2. I will change it afterward. ddx of g of x at x is equals to 2. 1 is minus 16, 2 is 20, 3 is minus 20, 4 is 15, and 5 is 12. Now we'll solve one by one. Now first is ddx of f of g of x. That is f dash of g of x into g dash of x. At x is equals to minus 1. ddx of f of g of x at x is equals to minus 1. F dash of g of minus 1, g dash of minus 1. F dash of g of minus 1. What is the g of minus 1 is 2. The value of the g of minus 1 from the table is 2. And g dash of minus 1. G dash of minus 1 from the table is 4. F dash of 2. F dash of 2 is a minus 5. Minus 5 into 4 minus 20. Therefore, the third option is the correct one. Second, ddx of g of f of x minus 1 is g dash of f of x minus 1 into f dash of x at x is equals to minus 1. G dash of f of minus 1. The value of f of minus 1 is 3 minus 1 f dash of minus 1. What is f dash of minus 1? F dash of minus 1 is minus 3. It's a 3 minus 1, that is a 2. G dash of 2. G dash of 2 is minus 4. Minus 4 into minus 3, that is a 12. And hence the option 5th is a correct one. That is a 12. C. ddx of f of x minus 3, I had corrected here, at x is equals to 2. Therefore, its a derivative is f dash of f of x minus 3 into f dash of x at x is equals to 2. F dash of, what is the value of f of 2? The value of f of 2 is 2 and f dash of 2. F dash of 2 is minus 5. 2 is 2. 2 minus 3. F dash of 2. F dash of 2 is a minus 5. F dash of, this is the minus 1. F dash of minus 1. F dash of minus 1 is a minus 3. F dash of minus 1 is a minus 3. And overall that answer becomes plus. That is a plus 15. Answer C options has the fourth correct one. That is a 15. Next is a D. ddx of g of x is equals to g dash of g of x into g dash of x. At x is equals to 2. G dash of g of x, g of 2 into g dash of 2. G of 2, what is the value of g of 2? G of 2 is a minus 1 and g dash of 2. G dash of 2 is a minus 4. G dash of minus 1. G dash of minus 1. G dash of minus 1 is 4. And G dash of 2 is a minus 4. G dash of minus 1 is 4. The answer is minus 16. Hence, first answer. It's very interesting. D has the answer minus 16. Now the question number 3. Suppose that the function f and g their derivatives with respect to x have the following values at x is equals to 0 and x is equals to 1. Again, same type of the questions. We have given the values of x, functions and derivatives. Function is f of x, g of x, f dash of g of x. Now the first question, the derivative of f of g of x with respect to x at x is equals to 0 is at x is equals to 0 is ddx of f of g of x is equals to f dash of g of x into g dash of x. Now we want to find out at x is equals to 0. F dash of g of 0. What is the value of g of 0 is 1. And g dash of 0. G dash of 0 is 1 upon 3. G dash of 0 is 1 upon 3. Let's change it answer. Therefore, ddx of that is equals to minus 1 upon 9. Next is the derivative of g of f of x with respect to x at x is equals to 0. Ddx of f of g of x is g dash of f of x into f dash of x at x is equals to 0. G dash of f of 0 into f dash of 0. Now what's the value of f of 0? F of 0 is 1. And f dash of 0 is 5. G dash of 1 is minus 8 upon 3 into 5, that is a minus 40 upon 3. Next is third. ddx of, find the value of ddx of x raised to 10 plus f of x bracket raised to minus 2 at x is equals to 1. X raised to 10 plus f of x raised to minus 2. That is first derivative of the bracket, that is a minus 2 x raised to 10 plus f of x that bracket raised to minus 3 into ddx of x raised to 10 plus f of x that is equals to minus 2 x raised to 10 plus f of x bracket raised to minus 3, that is a 10 x raised to 9 plus f dash of x. At x is equals to 1, that is a minus 2. X is replaced by minus, that is 1 raised to 10, f of minus 1 raised to minus 3, 10 into 1 raised to 9 plus f dash of 1. Here is a minus 2, 1 raised to 10 means what? 1, f of 1, the value of f of 1 is 3 raised to minus 3. That's a 10, f dash of 1. F dash of 1 is a minus 1 upon 3. Therefore, it is a minus 2. 1 plus 3 is a 4 raised to minus 3. 29 upon 3. That is a minus 2 into 1 upon 4 raised to 3 into 29 upon 3. That is a minus 29 upon 96 if we simplify it. Now next is the derivative of f of x plus g of x with respect to x at x is equals to 0 ddx of f of x plus g of x f dash of x plus g of x into ddx of x plus g of x, that is f dash of x plus g of x. X is 1, g dash of x at x is equals to 0. Therefore f dash of 0 plus g of 0, and the value of g of 0 is 1, 1 plus g dash of 0, and the g dash of 0 is 1 upon 3. G of 0 is 1 into g dash of 0 is 1 upon 3. Therefore you get f dash of 1. What is f dash of 1 then? F dash of 1 is a minus 1 upon 3 into 4 upon 3. That is nothing but minus 4 upon 9. This is the question. Very simple question. If you want to see the answers of all these questions, you can see this here. Question number 2. I am repeating again this question number 2 and question number 3. If you want to write down from the board, you can write. This is the question number 2. All correct pairs are solved here. B. These are the values substituted here. Next, for C, derivative of f of x minus 3 is f dash of x minus 3 into f dash of x. This is the value. 15 is answer for the. Now D is g dash of g of x into g dash of x. You can write down this also. And this is the question number 3. If you want to write down the answer. Now see this, the first one. This is the second. This is the third one. Fourth one. Just I had explained also. And in this way, the question number 2 and 3 we have completed. Now we'll see the next question. Question number 4. Now these are the regular questions. That's why I am differentiating here. Differentiate the following with respect to x. Sin 2 tan inverse in bracket root of 1 minus x upon 1 plus x. y is equals to sine 2 tan inverse in root of 1 minus x upon 1 plus x. And we have the substitution here. It's given in the see this step by steps again. Y is equals to 2 tan inverse in root of 1 minus x. I am again showing this. Thus, put x is equals to cos theta. Theta is equals to cos inverse of x. Therefore, y is equals to sine in bracket 2 tan inverse in root of 1 minus cos theta upon 1 plus cos theta. In the textbook, for the hint, we are given that is put x is equals to cos of 2 tan theta, but I have taken only single theta. Doesn't matter. Y is equals to sine 2 tan inverse in root of 2 sin square theta by 2, 2 cos square theta by 2. You are getting tan square theta by 2. Square and root get cancelled, and you are getting that is y is equals to sine 2 tan inverse of, that is a tan inverse, square and root get cancelled, tan inverse of tan of theta by 2. Therefore, you are getting 2 theta by 2, 2 get cancelled, sine inverse of theta. Okay. Now, this is the sine inverse. No, it is not sine inverse, it is a sine theta. But what is the theta? Theta is a cos inverse of x. Now differentiate this with respect to x. Therefore, dy by dx is equals to cos of cos inverse of x into derivative of cos inverse. That is a minus what is the derivative of cos inverse? That is the derivative of sine of cos inverse is the cos of cos inverse into ddx of cos inverse. Now here is a cos of cos inverse of x, that is x, and derivative of that cos inverse of x is minus 1 upon in under root of 1 minus x square. Therefore, dy by dx is equals to minus x upon in root of 1 minus x square. This is the answer. Dy by dx is equals to minus x upon in root of 1 minus x square. Now see this again answer. Y is equals to, this is the substitution. I have taken substitution, x is equals to cos of theta. In hint we have given that put x is equals to cos of 2 tan theta. You can take any. Theta is equals to, apply the formula. Therefore, you will get y is equals to sine 2 tan inverse in root of tan square theta by 2. Therefore, y is equals to sine 2 tan inverse of tan of theta by 2. Therefore, sine of, that is a 2 into theta by 2 sine theta. But what is the theta? Cos inverse of x. And derivative of cos is, sine is cos of cos inverse into derivative of cos inverse, which is minus 1 upon in root of 1 minus x square. And this is the dy by dx. And hence dy by dx is equals to minus x upon in root of 1 minus x square. Next is second, y is equals to sine inverse in bracket cot inverse in root of now again I will show this, that is it is a in direct manner. Dy by dx is equals to minus 1 upon 2. See this here. y is equals to sine square cot inverse of in root of 1 plus x upon n. What is the substitution? That is x is equals to cos of theta. You can take x is equals to cos of 2 times theta also. Therefore sine square tan inverse. Now this cot can be converted into the tan. That is the cot inverse of x is equals to tan inverse of 1 upon x. Therefore this becomes tan inverse in root of 1 minus x upon 1 plus x. Put x is equals to cos theta. Theta is equals to cos inverse of x. Therefore sine square tan inverse in root of 1 minus x upon 1 plus x. Therefore sine square tan inverse in root of, what is x? X is equals to cos theta. 1 minus cos theta upon 1 plus cos theta. That is the sine square tan inverse of in root of 2 sine square theta by 2. That is a 2 sine square theta by 2 and 2 cos square theta by 2. These 2 get cancelled. Then for you will get the tan of theta by 2. Tan inverse of tan of theta by 2 is a theta by 2. That is the sine square theta by 2. Therefore, what is the sine square theta by 2? This is again one more important. That is the 1 minus cos of theta upon 2. Split up this 1 upon 2 minus 1 upon 2 cos theta. Therefore, y is equals to 1 upon 2 minus 1 upon 2 cos of, what is the theta? Theta is the cos inverse of x. Therefore, this is cos inverse. Now, what is the cos inverse of cos inverse of x is x. Now, differentiate this. Derivative of 1 upon 2 is 0 and derivative of x is 1, which is dy by dx is equals to minus 1 upon 2. And this is answer. Now, the next is third is y is equals to tan inverse root x in bracket 3 minus x upon 1 minus 3x. Y is equals to tan inverse root x in bracket 3 minus x upon 1 minus 3x. Now put here root x is equals to tan theta and theta is equals to tan inverse of root x. Y is equals to tan inverse root x in bracket 3 minus x upon 1 minus 3x. That is the tan theta 3 tan square theta, because there is x, 1 minus 3 tan square theta. If you multiply it, then you will get 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. That is the tan inverse of, this is nothing but the expansion of tan of 3 theta. That is equals to tan of 3 theta is a 3 theta. Now differentiate this with respect to x. Theta is a tan inverse of root x. Therefore 3 dy by dx is equals to 3 upon in root of, that is 1 plus root of x bracket square ddx of root x. What is the derivative of root x? 1 upon 2 times root x. That is a 3 plus x 1 upon 2 root x. That is a 3 by 2 root x in bracket 1 plus x. Three upon 2 root x in bracket 1 plus x. Let's see this again answer. Root x is equal to tan theta, theta is equal to tan inverse of root x. Y is equal to tan inverse tan theta minus 3 tan square theta upon 1 minus 3 tan square theta. That is the 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is nothing but the tan of 3 theta. Tan inverse of tan of 3 theta is a 3 theta. Theta is the tan inverse of root x. Now differentiate it. You will get dy by dx is equals to 3 upon 1 plus root of x bracket square into radians of root x, that is 1 upon 2 root x, and overall the answer is dy by dx is equals to 3 upon 2 root x in bracket 1 plus x. Therefore dy by dx is equals to 3 upon 2 root x in bracket 1 plus x. Now the next is fourth one, y is equals to cos inverse in bracket root of 1 plus x minus root of 1 minus x upon 2. Now put x is equals to cos of 2 times theta. Therefore 2 theta is equals to cos inverse of x, and theta is equals to 1 upon 2 cos inverse of x. Now substitute that. Y is equals to in root of 1 plus cos of 2 times theta in root of 1 minus cos of 2 times theta. That is, now apply the formula cos inverse. What is the 1 plus cos of 2 times theta? That is a 2 cos square 2 theta upon 2, that is a 2 cos square theta, root sine 2 sine square theta upon 2. Cos inverse root 2 upon 2, that is 1 upon root 2 cos theta by y is equals to cos inverse 1 upon root 2 cos theta root 2 upon 2 cos of theta minus root 2 upon 2 sin theta. Y is equals to cos inverse 1 upon root 2 cos theta minus 1 upon root 2 sin theta. Now again this is the expansion of, that is cos inverse of cos of pi by 4 into cos theta minus sin of pi by 4 sin theta. That is a cos of pi by 4 plus theta. That is equals to, y is equals to pi by 4 plus theta. But what is a theta? Theta is 1 upon 2 cos inverse of x. Therefore dy by dx is equals to plus 1 upon 2 cos inverse of x. Differentiate this with respect to x. The derivative of pi by 4 is 0 minus 1 upon 2 in root of 1 minus x square. And that's why dy by dx is equals to minus 1 upon 2 in root of 1 minus x square. Now the fifth one, so you can write down from the board. Separate it. I will scroll down, you can write down from the screen. Just we have completed this type of all the examples in the exercise. Now the next is fifth one. Y is equals to tan inverse x upon 1 plus 6x square and cot inverse 1 minus tan x square upon 7x. That is tan inverse x upon can be written as 3x minus 2x. What is here? So numbers whose product is 6x square, 2 and 3. Now this x can be written as 3x minus 2x upon 1 plus 3x into 2x. Now here is a cot inverse. Cot inverse of 1 upon x is a tan inverse of x. Therefore here will be 7x upon 1 minus 10x square. 7x upon 1 minus 10x square. Therefore, y is equals to tan inverse of 3x minus tan inverse of 2x plus, now what are the two numbers whose product is 10 and sum is 7? 5 and 2, 5x and 2x. 5x and 2x. 5x plus 2x upon 1 minus 5x into 2x. That is the tan inverse of 3x minus tan inverse of 2x plus tan inverse of 5x plus tan inverse of 2x. Now these two get cancelled. Differentiate this. That is, y is equals to tan inverse of 3x and tan inverse of 5x. Their derivatives. That is 1 upon 1 plus 9x square into ddx of 3x plus 1 upon 25x square into ddx of 5x is 5. This is the answer. Therefore, dy by dx is equals to 3 upon 1 plus 9x square plus 5 upon 25x square. Now the next is, also you can see all this. This is y is equals to, you can write down from this board in this way. Now we'll see the next example. Y is equals to tan inverse in root of 1 plus x square plus x upon in root of 1 plus x square minus x. Now the sixth example, here we have substitution. X is equals to tan theta, theta is equals to tan inverse of x, tan inverse of in root of 1 plus tan square theta plus x means tan theta upon in root of 1 plus tan square theta minus tan theta. That is y is tan inverse of in root of 1 plus tan square theta is a sec square theta plus tan theta upon in root of sec square theta minus tan theta. That is y is equals to tan inverse in root of sec theta plus tan theta upon sec theta minus tan theta. Now multiply the numerator and the denominator by sec theta minus tan theta. Sec theta plus tan, that is the conjugate of sec theta minus tan theta, multiplied sec theta plus must be here, I think, plus sign, the mistake, plus sign, multiplied n and d by sec theta plus tan theta. Then numerator you will get the bracket square and denominator you will get sec square minus tan square theta. Its value is 1. sec square theta minus tan square theta. Therefore, tan inverse of 1. Therefore, y is equals to tan inverse sec theta plus tan theta, bracket complete. Therefore, y is equals to tan inverse sec theta means what? 1 upon cos theta, plus tan theta means what? Sin theta upon cos theta. Now y is equals to tan inverse 1 plus sin theta upon cos theta. Now again this is conversion, that is a 1. 1 means what? 1 plus sin theta means what? This is the regular cos of theta by 2 plus sin of theta by 2 brackets. But cos theta is a cos square theta by 2 minus sin square theta by 2. That is a plus power will get cancelled from the numerator. You will get cos of theta by 2 plus sin of theta by 2 upon cos of theta by 2 minus sin of theta by 2. Therefore, y is equals to tan inverse 1 divide n and dy now cos of theta by 2. This we have solved number of the time in this example. Divide n and dy cos of theta by 2. Then you will get tan inverse of 1 plus tan of theta by 2 upon 1 minus tan of theta by 2. And now this is the expansion of tan of pi by 4 plus theta by 2. That is a tan of pi by 4 plus theta by 2. Therefore, y is equals to pi by 4 plus theta by 2. Now differentiate this with respect to theta or x. We have the value of the theta. What is the theta? That the theta is equals to tan inverse of x. dy by dx is equals to derivative of pi by 4 is 0, 1 upon 2, and tan inverse of x, its derivative is 1 upon 1 plus x square. Therefore, dy by dx is equals to 2, that is 1 upon 2 in bracket 1 plus x square. This is the answer. Now see this once again, this question. I will scroll down, you can write on this. Multiplied n and dy plus sec theta plus tan theta. Then you are getting sec theta plus tan theta bracket square. Sec square theta minus tan square theta is 1. Bracket square and root get cancelled. Tan inverse of sec theta plus tan theta. 1 upon cos theta plus sin theta upon cos theta. 1 plus sin theta upon cos theta. This is the cos of theta by 2 plus sin of theta by 2 bracket square. And cos theta means what? Cos square theta by 2 minus sin square theta by 2. 1 plus power will get cancelled. That is the cos of theta by 2 plus sin of theta by 2 into cos of theta by 2 into sin of theta by 2. And here is a a square minus b square. Then plus will get cancelled. Minus to the denominator. Plus to the numerator. Divide n and dy. Cos of theta by 2. 1 plus tan of theta by 2 upon 1 minus tan of theta by 2. This is nothing but the expansion of tan of pi by 4 plus theta by 2. And that is y is equals to pi by 4 plus theta by 2. But what is the theta? Tan inverse of x. Therefore, dy by dx is equals to 1 upon 2 into 1 upon 1 plus x square. And hence dy by dx is equals to 1 upon 2 in bracket 1 plus x square. Now the question number 5. First, if in root of x, y plus x plus in root of y minus x is equals to c, then show that dy by dx is equals to y upon x in root of y square minus x square minus 1. Therefore, in root of y plus x plus in root of y minus x is equals to First of all, that is a c squaring on both sides, but I had written c square. It is not the c square, it is only the c. By mistake, I had written it. This is the c square. I had made the mistake, that is only the c. It's a bracket square. I will show here. 1. Now I had corrected it. That is the root of a y plus x plus root of y minus x is equals to c. Squaring on both sides, root of y plus x plus root of y minus x is equals to bracket square is equals to c square now. Now first term square plus second term square plus 2 into first term into second term is equals to c square. Now the square of the root of y plus x is y plus x and square of the root of y minus x is y minus x. Now here is plus x and minus x get cancelled. You will get y plus y is a 2y plus 2 in root of y square minus x square is equals to c square. Therefore, dividing on both sides by 2. Therefore, y plus in root of y square minus x square is equals to c square upon 2. Now differentiate this with respect to x. Derivative of y is a dy by dx. In root of y square minus x square is a 1 upon 2 in root of y square minus x square into ddx of y square minus x square is equals to derivative of c square upon 2, which is 0. And that's why the dy by dx is equals to 1 upon 2 in root of y square minus x square into ddx of 2y into dy by dx minus 2x is equals to 0. And therefore dy by dx is equals to, here is, if we multiply 1 upon 2 in root of y square minus x square into 2y into dy by dx, you will get 2y upon 2 into in root of y square minus x square into dy by dx. Again 1 upon 2 in root of y square minus x square is multiplied with minus 2x, and that's why you are getting the minus 2x in root of 2 in root of y square minus x square. Now in this case 2 get cancelled. Therefore you are getting dy by dx plus y upon in root of y square minus x square into dy by dx is equals to x upon in root of y square minus x square. Now simplify this, take the dy by dx as a common, then in bracket you are getting 1 plus y upon in root of y square minus x square into dy by dx is equals to x upon in root of y square minus x square. Now simplify this, this is 1 into root of y square minus x square plus y upon in root of y square minus x square into dy by dx is equals to x upon in root of y square minus x square. These two get cancelled and hence you are getting the dy by dx is equals to x upon in root of y square minus x square plus y. And that's why here, that is again we are multiplying, that is the conjugate part of root of y square minus x square plus y. It's a minus. Therefore, multiply the numerator and the denominator by in root of y square minus x square minus y to the numerator and denominator. Therefore, to the denominator you are getting the y square minus x square minus y square. That is a plus y square minus y square get cancelled. You are getting x upon x square. This x get cancelled, and that's why it is a minus dy by dx is equals to minus 1 upon x minus y plus in root of y square minus x square, and therefore overall dy by dx is equals to y upon x minus in root of y square minus x square upon x, and that's why the answer is dy by dx is equals to y upon x minus in root of, if we divide it, that is y square upon x square minus 1, and hence the answer. This is the answer. Now if you want to write from the board, you can write down. Simplification is here, dy by dx plus this 2 get cancelled, y upon in root of y square minus x square into dy by dx minus 2x upon 2 in root of y square minus x square is equals to 0. Therefore dy by dx plus y upon in root of y square minus x square into dy by dx is equals to x upon in root of y square minus x square. If we take dy by dx as a common, then you will get 1 plus y upon in root of y square minus x square into dy by dx is equals to x upon in root of y square minus x square. Now simplify this. That is a y square plus x square in root of plus y upon in root of y square minus x square is equals to into dy by dx is equals to x upon in root of y square minus x square. Now these two terms get cancelled. Therefore dy by dx is equals to x upon in root of y square minus x square plus y. That's a dy by dx is equals to. Rationalize the denominator, that is multiplied n and dy in root of y square minus x square minus y. Therefore you will get x in root of y square minus x square minus y upon y square minus x square minus y square. Therefore you are getting, that is a x in root of y square minus x square minus y upon minus x square. This one x will get cancelled. That is minus 1 upon x in root of, that is minus 1 in root of y square minus x square. Therefore dy by dx is equals to y upon x minus in root of y square minus x square upon x. That's why dy by dx is equals to y upon x minus in root of y square minus x square upon x square. This is the answer that we want to prove. Now the next example. Now also you can write from here squaring this is the you can write to. Now the next problem. If x in root of 1 minus y square plus y in root of 1 minus x square is equals to 1, then show that dy by dx is equals to minus in root of 1 minus y square upon 1 minus x square see this here, apply the product rule. So see it's here. Next is, now see this, differentiate this with respect to x. Derivative of x is 1 into root of 1 minus y square plus x as it is. Derivative of root of 1 minus y square is 1 upon 2 in root of 1 minus y square into derivative of 1 minus y square, which is minus 2y into dy by dx plus, next is, that is the y into derivative of root of 1 minus x square, which is 1 upon 2 times in root of 1 minus x square into derivative of 1 minus x square is a minus 2x plus in root of 1 minus x square and derivative of y is a dy by dx is equals to 0. Now collect the terms of the dy by dx. Next is, here is a normal simplification, root of 1 minus y square minus xy. These two get cancelled, minus again xy, root of 1 minus x square plus root of 1 minus x square into dy by dx is equals to 0. Therefore Next is collect the term of the dy by dx. This is the first, and this is in root of 1 minus a square into dy by dx. Take the dy by dx as common, and these are the remaining terms. This is a plus, it becomes minus. This minus will become again the plus, and now simplify this. Now see this, I will show you again here. From this, you can write down now. That is x in root of 1 minus y square plus y in root of 1 minus x square. Their derivative, that is 1 in root of 1 minus y square plus x into derivative of root of 1 minus y square is 1 upon 2 times in root of 1 minus square into ddx of 1 minus square, which is minus 2y into dy by dx, plus y as it is. The derivative of root of 1 minus x square is 1 upon 2 in root of 1 minus a square into derivative of 1 minus a square is a minus 2x, plus the derivative of this y. That's we are getting the 4 terms here, 1, 2, 3, 4. Now the next is 2 to get cancelled, and simplification. Now collect the terms of the dy by dx. This is dy by dx and dy by dx. We are collecting it here. Therefore, in root of 1 minus a square into dy by dx minus xy in root of 1 minus y square into dy by dx is equals to xy in root of 1 minus y square minus root of 1 minus y square. If we collect the dy by dx, that is the root of 1 minus a square upon 1 minus xy upon root of 1 minus y square into dy by dx minus xy minus root of 1 minus y square into root of 1 minus a square upon root of 1 minus a square. Now these are the terms we can cancel from the both sides. They are common. Therefore, you are getting 1 upon in root of 1 minus y square into dy by dx is equals to minus 1 upon root of 1 minus x square. Therefore, dy by dx is equals to minus in root of 1 minus y square upon in root of 1 minus x square. Therefore, dy by dx is equals to, this is answer, minus in root of 1 minus y square upon 1 plus x square. Now the next question. Now we'll start the next question. If x sine of a plus y plus sine a cos of a plus y is equals to 0, then show that dy by dx is equals to sine square in bracket a plus y upon sine. Now we have x sine of a plus y plus sine a cos of a plus y is equals to 0, and it can be written as in this manner, that is a x sine of a plus y minus sine of a cos of a plus y. That's why you will get x is equals to minus sine a cos of a plus y upon sine of a plus y. Next is now differentiate this with respect to y. The y is a variable, therefore x is expressed in terms of the y. Therefore differentiate this with respect to y. Dx upon dy is equals to minus sine a in bracket sine of a plus y into ddx of cos of a plus y ddy of cos of a plus y. Because here y is a variable, we are differentiating with respect to y. Dx upon dy, that is a minus sine a in bracket sine of a plus y. This is a v into derivative of u minus u into derivative of v upon sine of a plus y bracket square, that is a sine square a plus y. That is a minus sine of a plus y. What's its derivative? Minus cos of a plus y And here doesn't require to write the into dy by dx because the variable is y. Cos of a plus y, derivative of sine of a plus y is a cos of a plus y upon sine square in bracket a plus y. Bracket complete. And now this is the expansion of cos of a plus b. We take the minus sign cos of a minus, that is sine square a plus y plus cos square a plus y. We take the minus sign, then sine square a plus y plus cos square a plus y, that is 1, that is sin a upon 1 upon sine square a plus y. Therefore dx upon dy is equals to sin a upon sine square a plus y, and that's why dy by dx is equals to 1 upon dx upon dy, and this we want to prove, that is 1 upon sin a upon sine square a plus y. Therefore dy by dx is equals to sine square a plus y upon sin a. This is what we want to do. Now again see this, if you want to write the answer of this question, express x in terms of y, x sin of a plus y plus sin a cos of a plus y, x sin a plus y minus sin a cos of a plus y. Therefore x is equals to minus sin a into cos of a plus y upon sin of a plus y. Differentiate with respect to y minus sin a and apply here the quotient rule. Sin of a plus y into dy of the cos of a plus y minus cos of a plus y dy of the sin of a plus y upon sin square a plus y. If we simplify it, then you will get, that is the derivative of cos is minus sin, here is a minus, that is the minus sin of a plus y into sin of a plus y minus cos of a plus y cos of a plus y. Now here is a minus sign. If you take the common, then you will get sin square a plus y plus cos square a plus y. That's the value is 1, and that is the answer. This minus minus will become plus sin a upon sin square a plus y. Therefore dx upon dy is equals to sin a upon sin square a plus y. Therefore dy by dx is equals to 1 upon dx upon dy, and that's equals to 1 upon sin a upon sin square a plus y. Therefore dy by dx is equals to sin square a plus y upon sin a, and hence the answer. Now the next is fifth question. Fourth question. If sin y is equals to a sin of a plus y. Now here again we can express x in terms of the y, that is y will be the variable, and then differentiate with respect to y, then find out dy by dx by using the definition of the inverse function. Now sin y is equals to x sin of a plus y. Therefore x is equals to sin of a plus y. X is equals to sin y upon sin of a plus y. Now differentiate this with respect to y. With respect to y, by mistake I had written there is a x, but it is a y. Therefore dx upon dy is equals to sin of a plus y into ddy of sin of y minus sin y into ddy of sin of a plus y upon sin square a plus y. That is a differentiate with respect to y. I have written here is x, by mistake I will change it. Now derivative of sin of y is a cos y, and derivative of sin of a plus y is a cos of a plus y upon sin square a plus y. Now this is the expansion of sin of a minus b. What is a? A is a plus y and b is a y. Therefore sin of a plus y minus y upon sin square a plus y. and that's why you will get sine of a upon sine square a plus y. But we want to find out, this is a dx upon dy, we want to find out dy by dx, and that is equals to 1 upon dx upon dy. Therefore 1 upon sine a upon sine square a plus y, and that is nothing but dy by dx is equals to sine square a plus y upon sine a, and hence dy by dx is equals to sine square a plus y upon sine a, and this is a proof. See this again. That is sine of y is equals to differentiate it with respect to y. This is the y. Therefore, you will get dx upon dy sine of a plus y into d dy of sine of y minus sine y into d dy of sine of. This is the sine of a plus y into cos of y minus sine y into cos of a plus y. This is the expansion of sine of a minus b. A is a plus y, b is y. Therefore, dx upon dy is equals to sine a upon sine square a plus y, and that's why dy by dx is equals to 1 upon dx upon dy, that is equals to 1 upon sine a upon sine square a plus y, and therefore dy by dx is equals to sine square a plus y upon sine a, and hence it is a proof. Now the next example is if x is equals to e raised to x upon y, then show that dy by dx is equals to y minus x upon x log x. Now take log on both sides. Log of x is equals to, if you take log on the both sides, log of x is equals to log of e raised to x upon y, but base and this e both are the same. Therefore it becomes x upon y, or this exponential can be converted into the log form. That is the log of x is equals to x upon y. Now here again very simple, we can express y in terms of the x, that is y is equals to x upon log x. Now differentiate this with respect to x. Therefore dy by dx is equals to log of x. Apply the quotient rule. Derivative of x is 1 minus x into derivative of ddx of x minus x into ddx of log x upon log of x bracket square. Therefore dy by dx is equals to derivative of x is 1 into log x minus x upon x into 1 upon x log of x bracket square. Therefore dy by dx is equals to log of x minus 1 upon log of x bracket square. This is 1. Therefore the value of log of x is x upon y minus 1 log of x bracket square. Now simplify this. X minus y upon y in bracket log of x bracket square. Therefore dy by dx is equals to x minus y upon log of x. The value of the log of x is y upon x upon y. Therefore y is equals to x upon log of x, the value of the y. x log of x minus y upon x log of x into log of x bracket square. Now one log will get cancelled there, x minus y upon x into log of x. Therefore, dy by dx is equals to x minus y upon x log x. And hence it is a proof. Now see this again. If you want to write x is equals to e raised to x upon y. Take log on both sides. This exponential is converted into the log also, or take log on both sides. Log of x is equals to x upon y is equals to x upon log x. Differentiate with respect to x, dy by dx. Apply the quotient to log x, derivative of x minus x, derivative of log of x upon log of x bracket square. Log of x, derivative of x is 1. X into derivative of log of x is 1 upon x. This x get cancelled. That is the dy by dx is equals to log of x minus 1 upon log of x bracket square. But what is the value of log of x? Log of x is x upon y. Substitute here. X upon y minus 1 upon log of x bracket square. Simplify this. X minus y upon y in bracket log of x bracket square. But what is the y? Y is x upon log x. One log get cancelled. Therefore, dy by dx is equals to x minus y upon x into log x, and hence dy by dx. This is the answer. Now next is sixth one. If y is equals to f of x is a differentiable function, then show that d2x upon dy square is equals to minus dy by dx bracket raised to minus 3 into d2y by dx square. Therefore, to prove this, dx upon dy is equals to 1 upon dy by dx. Now differentiate this with respect to x. Then you will get d2y by dx square, d2x upon dy square is equals to dd y of 1 upon dy by dx. That is a ddx of 1 upon dy by dx into by chain rule dx upon dy. Therefore, here is a by. It is a derivative of just like 1 upon x. What is the derivative of 1 upon x? That is a minus 1 upon x square. In the same manner, there is a dy by dx bracket square upon derivative of dy by dx, which is d2y by dx square. Now this step is important. 1 upon x. What is the derivative of 1 upon x? Is minus 1 upon x square into ddx of that x. In the same way, derivative of 1 upon dy by dx is dy by dx bracket square into ddx of dy by dx, which is d2y by dx square, and it has a minus sign. Now the next is this is written as dx upon dy is written as 1 upon dy by dx by 1. Therefore, normal simplification is here d2y by dx square, and this is dy by dx bracket raised to 1, bracket raised to 1 and 2. It becomes bracket raised to 3 and it comes to the numerator. Therefore, d2y by dx square is equals to dy by dx bracket raised to minus 3 d2y by dx square, and hence this is the proof. Now see this again. This we want to prove. Dx upon dy. Differentiate again. This step is important. It's a dx by the chain rule. ddy of. But here is a ddx of 1 upon dx upon dy into dx upon dy. Now it's a derivative. It's just like 1 upon v. Derivative of 1 upon v is a minus 1 upon v square into dv by dx. In the same way, it's a minus 1 upon v square into derivative of dy by dx, which is d2y by dx square. And here is a dx upon dy can be written as 1 upon dy by dx. Therefore, its power becomes 3. Therefore, minus d2y by dx square into dy by dx bracket raised to minus 3. But this all is equals to, this is a d2y by dx square. And hence, d2y by dx square is equals to minus dy by dx bracket raised to minus 3 into d2y by dx square. Now the next is question number 6. Differentiate tan inverse in root of 1 plus x square minus 1 upon x with respect to tan inverse 2x in root of 1 minus x square upon 1 minus 2x square. Let u is equals to tan inverse in root of 1 minus x square minus 1 upon x. V is equals to tan inverse 2x in root of 1 minus x square upon 2x square. Now here the substitution. Find du by dx. X is equals to tan theta, therefore theta is equals to tan inverse of x. Now in root of 1 plus x square minus 1 upon x, that is 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta is a sec square theta. Root here sec theta minus 1 upon tan theta. This is the 1 upon cos theta minus 1 upon sin theta upon cos theta. 1 cos get cancelled. If we simplify, you will get 1 minus cos theta upon sin theta. Therefore, 1 minus cos theta upon sin theta. That is a 1 minus cos theta means what? It is a 2 sin square theta by 2. And sin theta is a 2 sin theta by 2 into cos theta by 2. 1 sin theta get cancelled, 2 get cancelled. You will get tan of theta by 2. And again tan inverse of tan of theta by 2 is theta by 2. Therefore, u is equals to tan inverse of tan of theta by 2 is equals to theta by 2. That is 1 upon 2 tan inverse of x. Therefore, u is equals to 1 upon 2 tan inverse of x. Now differentiate this with respect to x. You will get 1 upon 2, 1 upon 1 plus x square. That is equals to 1 upon 2 in bracket 1 plus x square. Now again v is equals to tan inverse in bracket 2x in root of 1 minus x square upon 1 minus 2x square. Therefore, tan inverse x is equals to sin theta. Theta is equals to sin inverse of x. Therefore, v is equals to tan inverse of 2 sin theta in root of 1 minus sine square theta upon 1 minus 2 sine square theta. Therefore, you will get 2 sine theta in root of 1 minus sine square theta is a cos theta. That is 2 sine theta into cos theta upon cos of 2 times theta. 2 sine theta into cos theta means what? Sine of 2 times theta. That is the tan inverse of sine of 2 times theta. Therefore, tan inverse of tan of 2 times theta. Therefore, V is equals to 2 theta. That is what theta is. 2 sine inverse of x. Therefore, dv by dx is a 2 in root of 1 minus x square. Therefore, du by dv is equals to du by dx upon dv by dx. That is 1 upon 2 in bracket 1 plus x square upon 2 1 minus in root of 1 minus x square. Now simplify this. Therefore, 1 upon 2 in bracket 1 plus x square in root of 1 minus x square upon 2. That is in root of 1 minus x square upon 4. 2 into 2, 4, 1 plus x square. Therefore, du by dv is equals to du by du is equals to in root of 1 minus x square 4 in bracket 1 plus x square. Du by dv is equals to in root of 1 minus x square upon 4 1 plus x square. See this again. U and V substitutions. Find out the values separately. Tan theta, tan inverse of tan of theta by 2 is theta by 2 1 upon tan inverse of x. It's a du by dx. Same. V is equals to tan inverse. X is equals to sin theta. 2 sin theta into cos theta upon cos of 2 times theta. Tan inverse of tan of 2 times theta, that is a 2 theta. But what is the theta? Sin inverse of x. It's a derivative. 2 upon in the root of 1 minus x square. Therefore, du by dv is equals to du by dx upon dv by dx. And simplify this. That is 1 upon 2 in bracket 1 minus x square in root of 1 minus x square upon 2. And that's why you will get du by dv is equals to in root of 1 minus x square upon 4 in bracket 1 plus x square. Problem number 2. If that is a differentiate log of in root of 1 plus x square plus x upon in root of 1 plus x square minus x with respect to cos of log x. Now u is equals to. Now in this case we will simplify this. We will multiply numerator and the denominator. The conjugate of root of 1 plus x square minus which is the conjugate is a plus. That is a log of u is equals to log of in root of 1 plus x square plus x. It's a bracket square. Upon 1 plus x square minus x square plus x square minus x square get cancelled. You will get 2 times log of in root of 1 plus x square plus x Therefore, 2 log of in root of 1 plus x square plus x. Now differentiate this with respect to x. Du by dx is equals to 2 upon in root of 1 plus x square plus x into ddx of in bracket root of 1 plus x square plus x. Therefore, du by dx is equals to 2 upon in root of 1 plus x square plus x into derivative of root of 1 plus x square is 1 upon 2 times root of 1 plus x square into derivative of 1 plus x square, which is 2x, and x is 1. And again, if we simplify this, then you will get 2 upon in root of 1 plus x square plus x into x plus in root of 1 plus x square upon in root of 1 plus x square. Now 1, that is x plus in root of 1 plus x square get cancelled. You will get 2 upon in root of 1 plus x square. This is the du by dx. Now v is equals to cos of log x. Therefore, dv by dx is equals to minus sine of log x into derivative of log of x, which is 1 upon x. Therefore, dv by dx is equals to minus sine of log x upon x. And that's why du by dv is equals to du by dx upon dv upon dx. And that is a 2 in root of 1 plus x square upon minus sine log of x upon x minus 2x upon in root of 1 plus x square sine of log of x. Therefore, du by dv is equals to minus 2x upon in root of 1 plus x square into sine of log of x. Now you can see this again here. Differentiate this log of in root of 1 plus x square plus x upon in root of 1 plus x square minus x with respect to cos of log x. Now this is u multiplied in root of numerator and derivative root of 1 plus x square plus x. Then you will get u is equals to 2 log of in root of 1 plus x square plus x. And differentiate it. That is a 2 upon in root of 1 plus x square plus x into ddx of root of 1 plus x square plus x. That is a 2 upon in root of 1 plus x square plus x into derivative of root of 1 plus x square. That is 1 upon 2 in root of 1 plus x square into derivative of 1 plus x square, which is 2x. Derivative of x is 1. Now simplify this. That is a 2 upon in root of 1 plus x square plus x into x plus in root of 1 plus x square upon root of 1 plus x square. Now this term get cancelled and you are getting du by dx is equals to 2 upon in root of 1 plus x square. Now next derivative v is equals to cos of log x. That is the dv by dx is equals to minus sine of log x into derivative of log of x is 1 upon x. And therefore du by dv is equals to du by dx upon dv by dx. That is the 2 upon in root of 1 plus x square upon minus sine of log x upon x. And simplify it. Therefore you will get du by dv is equals to minus 2x upon in root of 1 plus x square into sine of log x. Third, differentiate tan inverse in bracket root of 1 plus x square minus 1 upon x with respect to cos inverse in root of 1 plus in root of 1 plus x square upon 2 in root of 1 plus x square. Now here is u is equals to in root of u is equals to tan inverse in root of 1 plus x square minus 1 upon x. X is equals to tan theta. Theta is equals to tan inverse of x. Find out the value of in root of 1 plus x square minus 1 upon x. That is in root of 1 plus tan square theta minus 1 upon tan theta. Therefore, 1 plus tan square theta is a sec square theta. It's a square root of sec theta minus 1 upon tan theta. Now sec theta means what? 1 upon cos theta minus 1 upon tan theta means what? Sin theta upon this cos theta. And this, if we simplify it, that is a 1 minus cos theta upon this sin theta upon cos theta. That cos will get cancelled, and that's why you will get 1 minus cos theta upon sin theta. Therefore, here is a 1 minus cos theta is a 2 sin square theta by 2 upon 2 sin theta by 2 into cos theta by 2. Now 1 sin theta by 2 theta by 2 get cancelled. You are getting the tan of theta by 2. This is, therefore u is equals to tan inverse of tan of theta by 2 is equals to theta by 2. Now the derivative of du by dx is equals to 1 upon 2 1 plus in bracket 1 plus x square. This is the first. What about the next? V is equals to cos inverse in root of 1 plus in root of 1 plus x square upon 2 in root of 1 plus x square. Therefore, put x is equals to tan theta. Therefore, V, that is a, you will get V is equals to cos inverse in root of 1 plus tan square theta plus 1. This is sec theta plus 1 upon 1 plus tan square theta sec square theta, that is a sec theta into 2. Now again simplify this. Cos inverse in root of cos theta 1 upon sec theta means what? 1 upon cos theta plus 1 upon 2 upon cos theta. And if we simplify it, then you will get cos inverse of in root of 1 plus cos theta upon 2. Normal simplification is here. 1 plus cos theta upon 2 upon cos theta. That denominator cos get cancelled, and you will get this. Now 1 plus cos theta means what? 2 cos square theta by 2 upon 2. These 2 get cancelled. Square and root get cancelled. You will get cos inverse of cos of theta by 2, which is theta by 2. Now V is equals to 1 upon 2 tan inverse of x, and its a derivative is a 1 upon 1 plus x square, and that's why du by dv is equals to du by d theta upon dv upon d theta. Therefore, that's numerator and denominator both are same. Therefore, du upon dv is equals to 1. There is by mistake, here is a x, but there is a du upon dv, that is equals to 1. In this way, we have completed up to the question number 6. The remaining part will be in the next video. Till then, goodbye.